So in this question, a good idea is to draw the coordinate plane. So there it is. And we have a point A over here, which is -4, 2. And then we have point B, which is 2, 4, up over here. There's a point C, and all we know is that it lies in the first quadrant, which is this quadrant right here. And that P, that is the x-coordinate in point C, is less than 2. So therefore it has to be somewhat to the left of this dot, but can't cross over the y-axis. And then we have to see that Q is less than 4. That Q has to be somewhere lower than here. So essentially, go from here, and it can go all the way down. It can't go past the x-axis because it has to be in quadrant number 1. So therefore, such a triangle, if we were to maximize it, would look something like this. And the reason we want to maximize it is because we want to find what the upper bound, or the maximum of the triangle is, and what the minimum bound, or the smallest possible area of the triangle could be. And anything in between that triangle, or those two areas, would be a valid area as well. And I'll get to that in a moment. First, here's my big triangle, the biggest possible triangle. And what are the points here? Well, we have -4, 2, and we have 2, 4, as we originally said. And this point right here, let us assume that it is touching the x-axis and that it is exactly 2 over. So this would be 2, 0. The reason is we know that this is the maximum bound that it can't quite attain, so it has to be less than whatever the area of this triangle is. And if we find the area of the triangle, we see here that our height is 4, from 4 to 0, that's 4. And then if we were to draw a line here to form a right triangle, that here would be our base, and that would be from -4 to 2, so that would give us 4 plus 2, which is 6. And so now we have a triangle with height 4, base 6. We use the formula to divide by 2, and we get areas equal to 12. So it can't quite touch 12, but if this coordinate right over here were 2.001, and this one over here were 1.9999, it would be pretty darn close to 12. Something like 11.99, whatever. But we know it could be 11.9. Now if we bring this point C here closer up over here to this point B, what's happening to the area of the triangle? Well, the triangle's shrinking as we bring this point up. Let's bring this point up even higher. Notice that now we have a triangle that is definitely quite skinny. As we bring this point up, it keeps shrinking down from this upper bound of less than 12 to 7, 6, 5, 4, 3, 2, 1, till we basically have a straight line. If I put the point right there, straight line. But if I drop that point just a tad, we get what almost looks like a straight line, but it's just really a very skinny triangle, which means that it can have an area that has to be greater than 0. So the area of our triangle has to be between these two ranges, and therefore all three of these could be possible areas.